Zenith. Looks like maybe a 15-inch or something. Let me see what that is. Looks like 13 or 14-inch TV. Alright, first thing we'll do, let's just plug it in and see what happens. If nothing happens, then we'll make some tests on it to see if it's worth fooling with. Now I'm plugging it into the electronic fuse. I'm going to set it at 2 amps. Okay. Alright, it's not on. Alright, how do we turn it on? That's the channel. Okay, there's no raster at all. Pretty clear we got bad capacitors in it. Alright, let's get to the back and test the CRT. If the CRT is open, that is going to mean this thing goes into the auction. Alright, let's see what I need. Horizontal oscillator section may not be working. Okay. Oh wow. Whew, that's got a big CRT in it. It has not been looked at. That socket was stuck on there with corrosion, so. Oh, okey-doke. Now, the filament on these is adjacent to the key. So, let me see what we get. Ha! The filament is good. Alright, so we probably just have a high voltage problem. We got to get the capacitors fixed so we have proper B+. It's good grief. Well, it looks like that does go into something. Ooh! Ooh! Oh, okey-doke. There's the TV. Alright, this we can get rid of. Alrighty. Wow, what a mess. I'm going to put the new capacitors underneath. Look who's here. Look at yeah. What? You coming over here to help? Hmm? You coming over here to help? Oh, you little sweetie. Okay. Now, supervising is one thing, but being a little furry nuisance is another. Okay, what I need is this here. No trouble. Alrighty. Now I got to see which ones are which. We've got 3 of them in here. No. triangular one. Okay, the 60 mics is this yellow. Okay, and then the other two are the bigs. Okay. All right. Okay. That's one of them. That's the 60. Wow. I tell you what I'm going to do. I'm going to just cut that terminal and leave all the wires connected to it. Make it easy. Now, I'm going to wash this off because the glue has to stick on there. Okay. Bluetooth. All right, this is the stuff that we use to hold stuff in. Shoe goo. Get it at any hardware store. About $3 a tube, $4 a tube, something like that. Okay. All right, now, somehow I gotta hold that there until I solder that wire. Don't know if I can do that. That might hold. Okay. Okay. All right, those are on there. Okay, this one goes to right here. And this one here goes there. Okay. Now I need 100 volts is fine. All right, now, okay, we put the right there. All right, now once that shoe goo hardens, these will be on there absolutely, and they will not come loose. All right, now we got this one has to go on the other side over there. They have a tremendous voltage drop. You won't get much voltage out of it. And it goes to right there. That's easy. All right, that gets us our silicon diode for that one. Now it's pretty good. Okay, see that one right there? It's another one. Okay, we got to fix that. Let me see what it is. I don't know where it is. I can't see it in the circuit. Holy shit. 10 at 500 volts. 10 at 300. 4. Woo! This one is a very busy condenser. A lot of high voltage on it. Okay, that's going to be in the horizontal section. Let me take a look and see if I can see what it is. Because it may not be serious. It might not be that significant. Okay, that's a high voltage. All right, where does it go? It's okay. So this is the high voltage right here. Now, what I'm going to do is I'm going to turn the power supply on, and we're going to apply B plus voltage to the whole set, but we don't have the filaments lit. So that way we're not pulling any current through the tubes. We're just looking at leakages. So if we can put 300 volts on it and have no serious leakage, we know all this crap is good. We're good to go. But if we have serious leakage, then we're going to have to trace it out, find out what it is. One of the capacitors will be bad. All right, I'm going to start off low. It's only making it to 140 volts, and it's pegging out. There's another capacitor in there that's screwed. It's going up. It's up to 170 volts. See, right now what it's doing is it's charging up all the capacitors in there. The ones we replaced, and this one right here. Okay, we're at 200 volts. Got 100 volts to go. Okay, the current is coming down. 20. 250. Keep going. Okay, current's going down. 294 volts, 295, 96, 297. Okay, 300 volts. That gets 300 volts on all the capacitors in there. That's 265 is the highest they show on the schematic. So 300 will give us enough over voltage to be okay. Okay, I'm going to let it sit there. Okay, we had the power supply connected to it for about 15 minutes, and this one's a little bit warm, not excessively. It only had about 10 milliamps of leakage. Okay, let me look at the other. Okay, we don't have any heat on them at all. Okay, this one's disconnected. All right, so I would say this one here doesn't warrant. It's just barely warm. If it was hot, then I'd say whoops, but it only has about 8 to 10 milliamps of leakage, so it's probably within its operating range. Take a look inside the high voltage cage. Oh my gosh. That flyback, it's one of those things they dipped in tar. Look at that, the tar is just, God. Okay, I'm going to put a piece of, I don't think that this thing will have any significant arcing. Let me see about the bottom. Okie doke. Well, I guess what I need is a cheater cord. Sit there and think, how many people nowadays do you think have got a cheater cord like this in their wire box? Ah. Okie doke. Okay, the thing that has to be done now, let's just see if anything blows up. First thing I'm going to do is I'm going to hook the meter onto the high voltage, onto the, okay. If I get onto here, and ground. Okay. Okay, well, shoot the juice to it. I've got the electronic fuse on it, so if something shorts or anything, it'll shut the power off right away. Okay. All right, the switch is not on. Okay. Now, what we're reading. All right, now let me turn it on. Okay, 70 watts. Okay. Tubes are lighting, so that means that okay, something is really badly screwed. Something's really badly screwed because we're only getting about 100 volts on the output of the doubler. Okay. It's the fusible resistor is heating up, so we got something badass shorting. Not shorting, but it's loading the crap out of it. All right, we know that the capacitors are okay because we put the 300 volts on it and we had no serious leakage. So something in the circuit itself is causing the load. All right, what I'm going to do, I'm going to go ahead and pull the horizontal output tube. Ooh. Okay, now that'll stop the filaments from lighting up. Now when I turn it on, we'll have no load. It'll be the same as if we're hooking a external power supply onto the point, and we should get our 300 volts. Nope. Nope. Okay, I got something wired wrong here. Something wired wrong. Okay, let me check this and see. What the hell? Oh, what a dork. I put the damn capacitor to the wrong place. Okay. Move the capacitor. Goes to there. I don't see anything wrong with that. Okay, this one here is the load. I'm going to pull that off of there. We'll see if the doubler's working. It could be something else that's shorted in there. The reason I was only getting half the voltage is because I hooked the meter to the hooked the meter to the wrong place. Oh my goodness gravy. Oh. What a complete... Oh. I hooked it onto there. That's the center tap of the doubler. This is the output here. Now. Alright, now let's go again. Okay, ground goes to chassis. Ooh, no, that's not right. Chassis, right here. And the plus here. Something's fucked. Woo! Going down, going down. Something's screwed here. The voltage went up to 250 volts and then it just it's something. I don't know what. Okay, so well, it goes up to almost 300 volts and then it just drops down. Oh, wait a minute. The filaments are lighting up. Try it now. Okay. So it's the TV itself is loading it down. All right, let's just let it cook and see what happens. I want to watch the current here. We're only running about 60 watts, 70. 80 watts. I don't think we've got a raster. No, there's no raster. Okay, so we've got, okay, and it's loaded it down to 150 volts. Okay, so, it's cooking. Something's cooking and loading the power supply way down. All right. Oh boy. Wow. That's going to be fun. Okay, what we can do, we'll disconnect the horizontal output. Okay. Now, this lets the entire set light up because we got the tube plugged in, but we've got the plate disconnected from the horizontal output. That disconnects the high-powered part of the circuit. Okay, let's try again. No, something is screwed. I'm not getting any voltage anymore. Not getting any voltage anymore. The B plus is only going up to 100 volts. Should be going to 300. not even 50 volts. Whew! Something is cooking. All right, has nothing to do with the tube. It is something else is cooking. Okay, let's hook the external power supply to it again and see if we can see where the leakage is. There's big leakage right now. So there's another capacitor in here that I did not catch that's leaking like hell. Yeah, one way to do it is connect a big power supply, external power supply to it, and run the voltage up, and then use the thermal imaging camera to find out which capacitor it is. Okay, so first we got to get the wires hooked back. Okay, now black to ground, and red. Ooh, doke. Now I'm going to turn the power supply on, and we'll see what it goes to. 100. That's weird. It's reading 300 volts on there. But it's not when we're getting the power from here. Okay, the symptom here is that I've got now, we just have the voltage doubler hooked up. This is the one that goes to the circuit. We got that disconnected. So if I look at this, okay, that's the plus, and the minus goes to the chassis. Okay, we're on the 250 volt scale, so it should go up to almost 300 volts. Double voltage doubler, 270 volts or so. Okay? No, it's only going to 60 volts. Something is badly zorched. Okay, we know the selenium rectifiers are not leaking because we can hook the power supply onto it and we get the full voltage. Now, I'm going to turn it on and look at the current draw. 70 watts, and there's nothing hooked to it. God, what in the hell? All right, thermal camera. We're just going to shoot the juice to it, and we're going to see what heats up. All right, this little baby here is worth its weight in gold. All right, let's see. Cap. And go to infrared. Well, it's the one thing I didn't test. That's this 7 ohm resistor here. And it's open. Probably, oh, for heaven's sakes. All right, get another one. 6 ohm one. I got a 7.5, but it's the same basic kind of resistor. Okay. Okie dokie. Okay, that's the top. And so we're going to okie dokie. All right. All right, there's nothing wrong with the connections. I'm still only getting 150 volts out of it. All right, I'm going to hook the external power supply onto it just for the heck of it. Make sure we don't have something leaking. Ground. All right, and positive goes to the input, which is goes to right here. All right, power on. Okay, it's reading 300 volts, which is what it should be reading. I don't know what's going on. I know the resistor's good now. Yeah, all our capacitors are good. It's a doubler, a voltage doubler. How in the hell? Okay, it was obvious we had trouble with a resistor. Okay, that resistor was burned out. Now it's not burned out. Now, okay, we could have a duty cycle situation here. I don't have a capacitor hooked to it. Without the capacitor, we're reading the average. It shot up there, but boy, it's pulling some current. Oh! Oh! Okay, power supply working. All right, where's the tube? Okay, now we're ready to go. Now I'm going to watch the current over here on the meter. $80 watts, 75 watts. Tubes are warming up. 90 watts, 100 watts. Okay, so we've got good B+. The B+ is got no hum on it. I didn't have the horizontal output tube connected, so we didn't have a raster. Okay, let's see if we get a raster. Okay, B+ is right at 280 volts. Whoa! Whew! Uh-oh, I think we just lost our resistor. No, it's good. It's good. Something shut the B+ off. All right. It's our cheater cord is a little bit wiggly here. Let me see if I tighten it up a little. Okay, that's good. Okay. All right, now we're reading again. The cheater cord was wiggly, loose. Okay, I don't know that we've got high voltage. Okie-doke. Let me get a screwdriver. Alright, let's see if we get an arc. Okay, we're getting an arc on the tube there. I don't think we can see it here. It's arcing on there. It just doesn't make much of an arc onto a screwdriver, but we're definitely getting an arc. So the horizontal oscillator is running. But there's nothing on the screen. Okay. Alright, we hook the ground to ground. Yeah, it's just unbelievable. Plus, and here. Okay, we got 12 kilovolts on the high voltage. Okay, very good. We're getting absolutely no trace of a raster. Okay, we got high voltage, we've got filament. Filament's lit. Okay, this is the brightness. I'm going to write that on there with a Sharpie here. Okay. Brightness. Vertical. Okay, this is the vertical. Okay, contrast. And the contrast is here. Okay. Okay. Ha! Ha ha! Okie dokie. All right, we got a raster. Okay, we got that, but we don't get any control at all. Okay, the horizontal, I can't tell. We got to get the vertical first, and we get no okie doke. Well, even that one's got crappy signal, but it's got a good picture, so I was happy with it. Now, okay, that just slides right into there. Hopefully. This isn't right. There. Now it's right. Alright, is it going? Okay. Okay. Well, we got it working. It looks pretty good. I need to adjust those two little rings in the back to center the picture, to pull it over. And the vertical linearity could be squeezed down a little, but I'm done with it. I'm done with it. Okay, very good. I don't have a good antenna, so I can't get any better channels. Okay, that's it.